Hi dear children, welcome to today's class. Today we are going to discuss the 12th standard 7th chapter, that is integrals. Suppose the derivative of a function is given. Okay, suppose that the derivative of a function is given and we need to find out the original function. Derivative of a function is given and we need to find out the original function. Derivative is given and we need to find out the original function. And second one, suppose we need to find out the area bounded by the graph of a function under certain conditions. Area bounded by the graph of a function under certain conditions. What can we do in these two cases? The first problem, that is derivative is given and we need to find out the original function. And the second one, we need to find out the area bounded by the graph of a function under certain conditions. These two problems led to the two forms of the integrals. These two problems led to the two forms of the integrals. The first one is indefinite integrals. The first one is indefinite integrals and the second one is definite integrals. The first one is indefinite integrals and the second one is definite integral. That means if the derivative is given and if we want to find out the original function, in that case the integration is indefinite integral. And if you want to find out the area bounded by the curve, then in that case the integral is definite integral. Actually, these two integrals together constitute the integral calculus. These two integrals together constitute the integral calculus. This integration is an inverse process of differentiation. This integration is actually an inverse process of differentiation. We know that d by dx of sin x is equal to cos x. d by dx of sin x is equal to cos x. In this case, we will say that sin x is an antiderivative. Sin x is an antiderivative or an integral of cos x, or an integral of cos x. Sin x is an antiderivative or an integral of cos x. Now, what is the derivative of sin x plus c? What is the derivative of sin x plus c? That is equal to, the derivative of sin x is cos x, and since c is a constant and we know that the derivative of constant is 0. So, the derivative of sin x plus c, that is also is equal to cos x. In this case, we can say that sin x plus c is an antiderivative of sin x plus c is an antiderivative of cos x. Just look at these two cases. We can conclude that thus antiderivatives of functions are not unique. Antiderivative of functions are not unique because the antiderivative of cos x, that we got sin x in the first case and here we got sin x plus c in the second case. We will get infinitely many antiderivatives corresponding to a function by choosing different values for c from real number set. Okay, if c is 1, we will get sin x plus 1. If c is equal to 0.5, then we will get sin x plus 0.5. That means we will get infinitely many antiderivatives corresponding to a function. Okay, that depends upon the value of c. Similarly, if d by dx x cube by 3. If we are considering the d by dx of x cube by 3, we know that the derivative is x square. And d by dx of x cube by 3 plus c, the derivative in this case, that also x square. So what we can conclude from here, this x cube by 3 and x cube by 3 plus c, these two are the antiderivatives of x square. Antiderivatives of the integral of x square. Okay, so this antiderivative is not unique. Now we are going to discuss some properties of this integrals. The integration, actually we will denote it by integral f of x dx. Okay, integration, actually we will denote it by integral f of x dx. This is indefinite integral, integral f of x dx. Indefinite integral means the limit of this integration is not given. Okay, the limit of this integration is not given. In such cases, that integration is called indefinite integral. In such case, that integrals is called indefinite integral. Okay, now this you should read it as integral of f with respect to x. Integral of f with respect to x. Now, this f of x in this integral is called integrand. Integrand. F of x in this integral is called integrand. And this x, that x is actually the variable of integration. X is actually the variable of integration. Now, integration is actually the process of finding the integral. Integration is actually the process of finding the integral. Now, the properties of integration. Okay, some properties of indefinite integral that we are going to discuss. Properties of indefinite integral. First one, the process of differentiation and integration are inverse of each other in the sense of the following result. That is, d by dx of integral f of x dx is equal to f of x. That means if this derivative and integral comes together, that get cancelled. If you have derivatives and integral together in one problem, then that get cancelled, and this result we will get it as f of x. So the d by dx of integral f of x dx is equal to f of x, and integral d by dx of f of x dx, that is also is equal to f of x. Integral d by dx of f of x dx is equal to f of x. Actually, we will use one arbitrary constant. This is called integral constant. Why we are using that constant? Because this antiderivative is unique, not unique. That's why we are using that constant. That constant is called integral constant. So by using property number 1, we can say that if you have derivative and integrals together in one problem, then that derivative and the integral get cancelled, because this differentiation and integration is actually the inverse process. Now the second property, two indefinite integrals with the same derivative led to the same family of curves, and so they are equivalent. Third property, if you have sum of functions, third one, if you have integral of f of x plus g of x into dx, integral of f of x plus g of x into dx. This we can write it as integral f of x dx plus integral g of x dx. Integral f of x dx plus integral g of x dx. Okay. This f of x dx means we need to integrate this f of x with respect to x. That variable of integration is x and the integrand is f of x. And the second case, the integrand is g of x and the variable of integration, that is x itself. Now the fourth property, if you have some constants, that is integral of k f of x dx, integral of k f of x dx. If you have any constant inside the integration, you can take it outside, that is k into integral f of x dx. K into integral f of x dx. If you have any constant in your integrand, just take it outside and integrate the remaining portion. And fifth property, that is the combination of this third property and the fourth property, that is integral of k1 f1 of x plus k2 f2 of x plus etc. plus kn fn of x into dx. If you have n functions, okay, and that n constants is also there, then this we can write it as k1 into integral f1 of x dx plus k2 into integral f2 of x dx plus etc. plus the last one, that is kn into integral fn of x dx. Kn into integral fn of x dx. Okay, these are some properties of indefinite integrals. So the indefinite integrals means here we don't have any lower limit and upper limit for our integration or the integral. That's why we are calling it as an indefinite integral. Okay, and the indefinite integral, if you have the differentiation and integral together, that get cancelled, that is the derivative d by dx of integral of f of x dx is equal to f of x itself. And in the final result of your integration, we will use one constant c, because the antiderivatives is not unique. That's why we are using one constant, and that constant is called the integral constant.